Let us discuss about the behavior of the inductance or the inductor in an AC circuit. Here we have got a circuit in which we have got an EMF source, AC EMF source, E is equal to E 0 sine omega t, and an inductor. And when the circuit is closed, the current I flows in the circuit. We know that when the current flows in the circuit, the current changes due to which the magnetic flux change, and by that change in magnetic flux that is linked with the inductor, there is a back EMF that is given by E dash. So we have this E dash is opposite to E, so we can have that by applying Kirchhoff's law. This is an EMF source, this is an EMF source, but in the opposite direction, we have got E plus E dash is equal to 0. Now we know that this back EMF E dash is equal to L di divided by dt, and we have got the negative sign because that EMF is opposite to the rate of change of flux. So we have that E minus L di divided by dt is equal to 0. So we have that E is equal to L di divided by dt. From here we have E is equal to E0 sine of omega t dt is equal to L di. Taking L to the denominator, we have E0 divided by L sine of omega t dt is equal to di. Now to get I here, we have to integrate this I. So integrating I, that is integration of di is equal to integration of E0 divided by L sine of omega t dt. Integral and differential cuts out. We have got I is equal to E0 by L is a constant, so taking it out of the integral sign. So we have E0 divided by L. Integration of sine omega t is cos omega t, and internal integration of omega t is 1 by omega. So we have got minus cos of omega t by omega is the integration. So I will be equal to minus E0 divided by omega L cos of omega t. We also know that cos theta is equal to sine of 90 minus theta. 90 minus theta. Applying here, we have got I is equal to minus E0 divided by omega L sine of pi by 2 minus omega t. Now giving it product by minus, our equation becomes I is equal to E0 divided by omega L sine of omega t minus pi divided by 2. Now this omega L is the reactance of this circuit, so we have that omega L is equal to XL, that is inductive reactance. So we have I is equal to E0 divided by XL sine of omega t minus pi divided by 2. As this is the reactance and E0 is the peak value of the EMF, so this quantity is the peak value of the current. So we can rewrite it as I is equal to I0 sine of omega t minus pi divided by 2, and E is equal to E0 sine of omega t. Taking a close look at these two equations, we have E is equal to E0 sine omega t and I is equal to I0 sine omega t minus pi by 2. It is clear that this I, the current in an inductor, lags behind this EMF by a phase angle of pi divided by 2. In a circuit containing an inductor only, the current lags behind the EMF by a phase angle of pi divided by 2, or that is 90. Discussing about the waveforms and the phasor diagram, we have the waveforms like this. If this is E is equal to E0 sine of omega t. Now, as the current lags behind it, that means we have to start from here by a phase angle of 90 degree. So the current is like this. So it is I is equal to I0 sine of omega t minus pi divided by 2. So in an inductor, the current lags behind the EMF by a phase angle of pi divided by 2. Let us take a look at the phasors. So we have here, this is x-axis, this is y-axis. Now we have got EMF. This is the peak value of the EMF E0. It is making an angle of omega t, but the current lags behind this E0 by a phase angle of 90 degrees. So we have to rotate it clockwise, as clockwise shows us lag, anti-clockwise shows us lead. So the current phasor will be like this, and this will be equal to I0, and this much angle will be equal to 90 degrees or pi divided by 2. But we can say that this angle is also equal to omega t, because this angle plus this angle is 90 degrees, this angle plus this angle is 90 degrees. As this angle is common, this angle is equal to this angle. So this is omega t and this is omega t. Now we have that the inductive reactance XL is equal to omega L, that is equal to 2 pi nu into L, where nu is the frequency, omega is the angular frequency. For DC, For DC, there are no number of cycles that is constant, having one direction only, so nu is equal to 0. For DC, XL is equal to 0. That means the behavior of inductor in AC and DC is different. When we connect an inductor on a DC supply, it offers no reactance, but when we connect it on AC, it offers reactance, and that reactance is proportional to the frequency. That means in India, where the frequency is 50 Hertz, the inductive reactance will be less. In USA or UK, where the frequency is 60 Hertz, the reactance of the same inductor will be more, because it is directly proportional to the frequency. Thank you.